Good morning, Math 10 students. Happy Thursday to everyone. Today we're going to be starting section 7.4. Okay, we did skip over 7.3. That was talking about using technology to graph, basically. We're going to skip that for now. We're going to do 7.4. And this section talks about how to solve a linear system of equations using this method of substitution. Okay, we'll also be learning, we just learned graphing. And graphing was fine. The only limitations to graphing are it's time consuming and we can't always get the exact answers, right? A lot of times we had to look and find an approximate one. So algebraically, using this method of substitution and the next one we're going to learn elimination are a lot more exact and a lot quicker. So substitution is one of my faves, so I hope you like it too. If you want to turn your books to 416, you can read over kind of 416, 417, basically gives you a little background on substitution. I'm going to go ahead and we're going to go over today example 1 on page 418 and check your understanding on 418. We'll do those two together. And yeah, we'll do that. And I think number 6 as well, we'll do that. So let's turn to page 418, example 1. It says solve this linear system. So I have it here. Now, if you see a linear system and you want to solve using substitution, the easiest way to do that is to find one of the variables, if possible, that is by itself. Okay, in this case, that's this y. All right, there's no coefficient with this y, so that's going to be our easiest variable to isolate or get by itself. So I'm going to start by doing that. So with substitution, the whole point is that you're going to take information from one equation and then substitute into the other in order to solve for one of the variables. So let's isolate that y. Okay. Y would be 5 minus 4x, okay? So I just took the 4x over there, or it could have been minus 4x plus y. It doesn't matter, those both mean the same thing. So now what I'm going to do is I'm going to take this equation, y equals 5 minus 4x, which all I've done is rearrange this one. Using this equation, every time I see a y, I'm going to substitute this information in. So let's go ahead and take this equation, and whenever I see a y, I'm going to substitute this. 5 minus 4x equals 7. Okay, so I took this equation, substituted in for y. Now I'm going to solve, and I can solve this now because I only have one variable, x. So I'm going to be able to find out what x is. So let's see here, 2x, let's use our distributive property here. Minus 20 plus 16x equals 7. Let's combine our like terms, okay? So we've got this, we'll have 18x. In the same step, let's move this negative 20 over here, it would be positive. So 18x equals 27. You could use your calculator or you could do this fractions. It would be 27 over 18, which is the same as 3 over 2, which is the same as 1.5. All right, so we now have solved our x variable and it equals 1.5. Now, with that information, if we know x, we could go back up to either of these initial equations, put the x in and solve for y. Now, one thing that I find very easy when I've done this, I've actually just already changed this equation to have y by itself. So I'm actually going to use this, and I'm going to put in the 1.5 for x, okay? So y would be, okay, 5 minus 6. Negative 1. So that was easy. My answer is that x was 1.5 and y is negative 1. Now if I wanted to check that, I mean it shows me in the book those are the answers, but if I wanted to check it, I could take my x value and my y value, put them into this equation, put them into this equation, and if they are correct, the left side will equal the right in both equations. These coordinates, or these values, this coordinate, has to work in both equations. Okay, so that was kind of a good introduction to what substitution is. So let's go on to the check your understanding next. Okay. Now this one's not as straightforward only because it does not have a variable without a coefficient for us to use. So we'll just have to do a little more work on that. So this one says 5x minus 3y equals 18. And then we have 4x minus 6y equals 18. All right, so again, using substitution, which is what they told us to do, there are no variables here without a coefficient. So we're going to have to do something different. One thing we could do is we could isolate one of the variables that, even though it has a coefficient, and what I mean by that is I could find out what x is over here by saying 5x would be negative 18 plus 3y, so x would be negative 18 plus 3y over 5. Okay, I could then take that, plug it in here for the x, and solve for x. Okay, so that's one way I could do it. I'm going to show you a different way that the book shows us as well, but this would absolutely work. It's just going to be a lot more fraction work, which I know some of you are not as partial to. Okay, but again, all I did there, I could pick any single one of these variables, isolate them. What I mean by that is get it all by itself on one side, okay, and you'll have it equal to something. Then you plug that into the other equation. Okay, I could have done it then. I'm not going to walk through that, but I'd encourage you to do that if you're feeling like it. I'm going to show you a different way. Now this, in this system, we're going to look if there's any easy way that I could make any relationship that the x and y's have. So for example, if I look at these x's, there's nothing I can multiply this by easily to get this, or vice versa. If I move over to my y's, on the other hand, 3 times 2 is 6. Okay, so keep that in your mind. 3 times 2 is 6. So really, this 6y, okay, could also be written as 2 times 3y, right? That means the same thing. Okay, so we're going to go ahead and use that information to kind of help us. First, what I'm going to do is I am going to isolate this 3y here, okay? So I'm going to say negative 3y equals 18 minus 5x, okay? And in our example, I said that I could rewrite this like this. So let's just go ahead and get this 3y to be positive, okay? So we talked about this in class before, but if I want my number here to be positive, I can multiply both sides by -1, and we notice that whenever you do that, really all that does is flip each sign to the opposite. So you can also just flip each sign, because we know that that's what happens if you multiply by a -1 on both sides. Remember, whatever you do to the left side, you can do to the right side and it will remain equal. So now all I've done is I've isolated for 3y, okay, rather than just one variable, like 3y, and I'll show you what we can do with that. So let's go ahead and I'm going to rewrite this equation. And remember, we said I could write it like this. Okay, so this is the same as this, okay? These two are equal. All I did is instead of putting 6y, I put 2 times 3y. Okay, everything else is the same. So now, remember my earlier one, I found that 3y equaled this. So now we can substitute this in here. So 4x minus 2, oh, there's 3y. Let's put this, negative 18 plus 5x is 18. Now we're down to one variable, x, so we can solve this. So let's go ahead and do that. 4x plus 36 minus 10x equals 18. I just used my distributive property there. Okay, let's combine our like terms. This would be negative 6x equals 18 minus 36, right? 36 here would be negative here. So negative 6x equals negative 18. Let's divide both sides by negative 6. I'd be left with x equals 3. Okay, we got our x is 3. Awesome. Woohoo! Now that we got our x, let's go ahead and solve for our y. I can do that by taking this x value and placing it in either this equation or this equation. It doesn't matter. Or if I want to use this, I can also use that, because this is the same as this, right? I've just rearranged things. So let's go ahead, I like to put it in here. So 3y will equal negative 18 plus 5. Let's put in our 3 for x. 3y equals negative 18 plus 15. 3y equals negative 3. Y equals negative 3 divided by 3. Y equals negative 1. Woohoo! Okay, so there are two answers. We had x is 3, y equals -1, and that is what the book has as well. So we did that correctly. Again, I could check that by putting those variables back in, and my left side must equal my right side in both equations, not just one, both, for that to be the correct answer. All right, so that was check your understanding number 1 on page 418. Okay. All right, let's also, while we're together like this, go to our questions, and I'm going to go over number 6. This is on page 425 now. Let's go over number 6, I. Okay, number 6 says, in each linear system, identify two like terms and say how they're related. So that's just like what we just did in the last question, so I just want to do another one for you guys. Okay, let's do that. So let's write it down. It says 2x minus 3y equals 2, 4x minus 4y equals 2. Okay, great. So they want us to look at the like terms, by that they mean x's and y's. And let's see if there's an easy way that they're related. So if I look at the x's, 2x and 4x, I do see something quickly. I know that 4x could be rewritten as 2 times 2x, right? If I looked at the y's, there's nothing straightforward. So this is the information they're looking at, right? Saying that 4x is equal to 2 times 2x. So let's see, is that all they wanted for, yeah. And then in part B, it says to solve using that information. So let's go ahead, let's solve this using that information. So what I'm going to do, I'm going to rewrite this one right here using this information. So rather than 4x, I'm going to write 2 times 2x minus 4y is 2. Okay? So these are equal. I've just rewritten it with that new information. And up here, what I'm going to do is I'm going to isolate my 2x so that I can use it in substitution. So 2x in this case would be equal to 2 plus 3y, right? If I add 3y to both sides, it'll cancel here, it'll be on the other side. Now, when I take this equation, I can substitute this information in. So I'm going to say 2 times, and rather than writing 2x, I'm going to say 2x is equal to 2 plus 3y minus 4y equals 2. Okay, great. Now we're down to one variable and we'll be able to solve. We're going to be able to solve for y. So let's use our distributive property here. Okay, combine your like terms. 2y. I'll bring this 4 over here at the same time. 2y equals -2, so y would be -2 divided by 2, which is -1. Great, so now we know what our y value is. How are we going to get our x? So we can take our y and substitute it into either of our original equations or one of the things we've moved around a little bit. And I think I will substitute my y into this one. So I'm going to use this. 2x equals 2 plus 3. What do we say y was? -1. 2x is 2 minus 3. 2x equals -1. X is going to be -1 over 2. All right. Very good. So that was 6, A and B. And I did the I one. So you know I'll be assigning you one to do as well. Okay, that's it for my teaching for today. This is the type of thing that the more you practice, the more you do, the easier it will get for you. So I'm going to assign a few questions for you to try. And if you're finding you've got it down, then you could stop at that. But if you need more practice, please do more in some of these questions until you feel really comfortable with this method. Okay, so your assignment or your assigned questions, you don't have to pass this in today, are on page 425. I guess I already wrote that, but 425, number 4A, 5A, and then do 6A and B with part 2. I did the I, you did the I, or the 1, you did the 2. Okay, so now, again, when you're doing 4 and 5, If you're like, yeah, I got this, no problem, you can just do those ones, but feel free to plus more. Do more of those if you want to, especially on these questions, okay? Practice makes progress. All right, that's it for today. Thank you so much for watching. And as always, if you have questions, please be in touch. All right, bye for now.